All right. Well, welcome everyone to this session after lunch. Thank you all for joining. There's lots of interesting sessions at this conference, and it's always a competitive thing to determine which one to attend. So we appreciate you coming to this one. And we look forward to an engaging discussion. So I'm Matt Mayernik. I'm from the United States, the NSF National Center for Atmospheric Research. I'd like to acknowledge my co-chair, Gita Yadav, who's right here, who you will hear from shortly. So first, to get us started, we will do the land acknowledgement. So we will begin by acknowledging the traditional owners of this land, the Turrbal and Yugara people of the land that we're meeting on today in Brisbane, and pay our respect to the elders of those groups, both past and present. So this title of this session is An Evolving Role for Data Scientists in the Age of Intelligent Automation. I will also mention that I'm the editor-in-chief of the Data Science Journal, which is published by CODATA. And this session came out of discussions within the editorial board of our journal. Mark is who you hear from shortly, is the former editor-in-chief of the journal, and Gita is a member of our editorial board. We'll have a fewer speakers than we were planning, but other speakers who were part of the session originally were part of the editorial board as well. And so the discussions really came out of the changing nature of data science, what the Data Science Journal should be publishing, and I'll say a little bit more about this shortly. And questions came from Simon Hodson, who's the director of CODATA, who you heard from in the plenary this morning if you attended that. What should CODATA, World Data System, the International Science Council, and the many international scientific unions and associations be doing about the changing nature of data science and the science of data? How should these organizations respond? How should we respond as a community? How can we reflect changes in this field in our actions, our programs, the conferences, our initiatives, our journals, and so on? So that was kind of the originating point of this session. And so what we're going to do is have a few talks on that topic and then engage all of you in discussion. And really, we're hoping to have this be quite interactive. So at any point, please feel free to raise your hand and bring up topics and comments that you have on these topics. So I'm going to do a brief introduction here, saying a bit more about the Data Science Journal and the kind of theme of the topic session. Then I'll turn over to Gita, who's also going to represent one of our speakers who had to miss the session, Deb Mohanty. Mark will then give a talk, and we may have an online talk. We're still uncertain, but we may not have a final speaker online. But regardless, we'll then go into open discussion, and we're really interested in having your thoughts on where data science is going and where it should go, and how our community should be responding to that. So just to do a quick introduction to the session again and the Data Science Journal. So I guess first a quick question, who is familiar with the Data Science Journal, those of you who are here? A few folks. Anybody who's authored a paper? Anybody who served as a reviewer? All right, well it's the same group, so we appreciate all of you. For those of you who didn't raise your hand, we invite you to take a look at the journal, to consider if your papers might fit in, and also to sign up for peer reviewers. Even though peer review is a challenging thing in today's environment, it's still essential part of our process, and we see as essential role in scientific communication. So just say a bit more about the journal, again, setting the stage for this idea of evolving data science. The journal was created by CODATA, still operated by CODATA, which is one of the sponsors of our meeting. It was first published in 2002. To our knowledge, being Mark and myself, it was the first journal with the term data science in the title. It's possible somebody could refute that, but we have not found any evidence to the contrary thus far. But as such, 2002 was, 20 plus years ago at this point, was quite substantially before a lot of the current interest in data science started, which I would say is more around 2010. So as you can imagine, the conception of what data science was at the originating point differed, and still to a certain extent differs from current conceptions of data science that you might see in other discussions at other conferences. There was a great session yesterday that some of you may have attended, led by Christine Kirkpatrick. It focused on the idea of bridging the gaps between data science and data stewardship. Probably if you were to look at the journal with a new eyes, much of the work published in there would probably be more categorized as under the data stewardship category than the data science category by most observers. Data science as it's understood today would be perhaps not as common in our journal. But I see that, and I think Mark and I have discussed this in the past, as a strength of the title and a reason to keep it. to make the point that data science should be including things like stewardship and the topics that we're discussing in CODATA and at this workshop. Another speaker in the session yesterday, Kirk Bourne, he described much of the work that happens at IDW as under the label of data engineering. And so again, maybe that's a term that we could discuss here. But regardless of the topics or the sort of titles that you might go under, this is how we think of kind of the scope of the journal and how we conceive of data science. So our focus is on data, notably research data. This is from the About page of the journal, how we describe it for potential authors. DSJ articles should faithfully represent data as an important topic in the research, discussion, or analysis, how data is part of the problem, solution, or both. Related cross-cutting topics may also be relevant. But for all topics, submissions should make an effort to demonstrate wider significance and application, say something about the science of data more generally. So one of the ways that we might differ in the way we interpret data science from other journals in this space is the focus on the paper has to be about the data. So we're looking for the science of data, not necessarily science with data. And I think partly that's a sort of a boundary question, right? If science with data is data science, then what isn't data science in today's world, since almost all science involves data? But also as a way to keep the focus on the data. So the most common type of paper that we reject is something that's focused on algorithms. Even they might use a lot of data, they might have something that is very data intensive, but the focus of the paper is on the algorithms and learning about the algorithms. So I think that's something that we see as distinguishing ourselves. Regardless of that, sorry, I keep pushing the wrong button. This is a word cloud that I did quite quickly. So, as with all word clouds, it's entertainment more than analysis. But of the first 4 years, this is purely taking the titles of articles published in the Data Science Journal, and then the last 4 years. And so you can see certainly there's a lot of continuity, data being the big focus. If you look farther, there's some terms that are in common. A lot of the early work was on databases. So chemistry databases, crystallographic databases. You see both database and databases showing up in that one on the top left. We don't have a lot of papers on databases per se anymore, so that's something that changed. You see XML on the top left. People still use XML, but they don't write papers about it anymore. So some of those things have changed. It's a little bit hard to see down here, but I'm not sure if you can see this, but machine and learning starting to show up. They're separated in this word cloud, but both show up 6 times in that. So I think we can assume they're probably from the same papers. So there's both continuity, but also change. But something we're not seeing, for example, is AI. This is not a topic that we've really focused on yet in our journal. But as we can see from kind of this whole conference, as the volume, variety, and velocity of data continue to accelerate, the role of data science is undergoing profound transformation. In the age of intelligent automation, large language models, which we heard about this morning, ubiquitous sensing technologies, and so on, data science has become a vital pillar of policy, ethics, infrastructure, and decision-making across domains. As we see at this conference in every session, the scientific community, though, places distinct demands on data science, such as the need for provenance, traceability, transparency, fair principles. They're not necessarily prioritized in commercial or governmental applications of data science. So it's important for us to really be very vocal about what are the distinct aspects of data science that we need to keep in mind within the scientific data community. So the panel is bringing together then some voices in all of your comments on this topic. What is the evolving role of data scientists in ensuring that automation and AI serve the long-term goals of science, integrity, and openness? So we're interested in exploring with you how data scientists must adapt and respond to both ethical, infrastructural, community-centric changes and expectations, how organizations like CODATA, the International Science Council, World Data System, the Research Data Alliance can shape this evolution and the changes in data science. So we'll have a couple talks, as I said, interactive discussion. We're considering the practical pathways for supporting the next generation of research-aware, ethically grounded, and infrastructure-integrated data scientists. So with that, I think we will change to our first speaker, which will be Gita. All right, you'll be able to flick through here.
Thank you, Matt. And once again, welcome everybody to this discussion on, as Matt has said already, what might be one of the most transformative questions that we may ask as data scientists. I'm going to assume everybody in this room is a data scientist in some fashion or another. The question is, what remains distinctly human in the, in the work of data science going forwards? We as a panel, and particularly you as our audience, we are hoping that we believe that we represent the full spectrum from infrastructure to ethics, from Arctic research to bioinformatics in the tropics and so on. And together we will be able to trace the contours of a new, more accountable and more open data science scenario. I invite each one of you to not only think about what data scientists do, but who we are and who we are becoming, stewards of integrity, mediators between machines and meaning, and architects of shared knowledge. I work in India, but I'm also part of several groups, particularly with the Data Science Journal as well as COERA, in trying to reform research assessment. But all of our work with data science happens, and now more and more of us are starting to use machine learning models, transformers, LLMs. The first slide. Right, Matt already just mentioned to you the 4 V's of big data, but there's also value there. Data has exploded in every dimension, but scientific data adds, the value to veracity as well, and therefore the demand for trust and traceability, transparency, can sometimes distinguish scientific data from commercial analytics. Therefore, at least from my point of view, the expanding role of a data scientist is, we used to be, model builders, analysts in the previous millennium, and then we became data stewards as the new century and millennium came in, and became the architects of infrastructure around us. In India, at least, I will be talking today about how we have developed the Indian Biological Data Center, but more importantly, how we've put together these communities like Semantic Climate, where we bring more and more data scientists together to build new tools. But what has happened more recently is that we are the people who are also the bridges for the community, between community and policy and data. And therefore, we've moved from crunching numbers to designing systems that embody ethics and reproducibility. And therefore, you, as a modern data scientist, are as much a custodian of integrity as you might be a coder. There are also very divergent expectations of data scientists in academia and in industry. Science is not just the industry, even though many of my friends who are in the industry insist that the cutting edge advances are only indeed happening in the industry. I believe that there is an ethics of difference. For commercial AI, of course, speed and scale and profits are very important, but for us as scientific data scientists, provenance and openness and reproducibility within CODATA as well, within the, as a member of the International Data Policy Committee of CODATA, I believe that provenance, openness, and reproducibility are becoming more and more important central themes that we are discussing within the IDPC. The human core remains that in this age of intelligent automation, to be able to understand the pattern that we have in the data is the real intelligence. And therefore, as automation grows more capable, our role as human is shifting from not just merely processing, but to interpreting, not just optimizing, but to understanding. And I believe that is where the human-machine interface can hope to grow stronger and farther. Today's panel, as Matt has already told you, I would be presenting, we have all of us here, but I would be presenting not just as the semantic climate speaker for this panel, but I will also present on behalf of Dr. Debasis Mohanty, the Director of National Institute of Immunology. Deb and I are not just close friends, but also collaborators, and we work together in India. And so therefore, he could not be here at the last minute, but his slides he sent to me. And so I'll be very happy to present to you an Indian perspective of how we are looking at AI and data science, particularly at the interface of biotechnology and AI. So I Yeah, I'm the co-founder of Semantic Climate. We are very keen on semantifying not just climate data, but biological data, converting it into the global knowledge graph. We are very much AI ready, and particularly for climate knowledge, we've had severe challenges of verifying climate data that is available to us, particularly the IPCC AR6 reports, and bringing this alongside of multilingualism in the global south. We are also performing semantic annotation and ethical AI in the context of the Semantic Climate Initiative, which just started, I would say, 3 or 4 years ago, together with collaborators and colleagues in Cambridge, where I was earlier working, and collaborators at TIB Berlin. We are very much interested in pedagogy and training for next generation AI-aware data scientists, and we welcome you to please join hands with us and collaborate with us to take this whole idea forwards. In my lab in India, we are using machine intelligence through protein language models, DNA language models. I was trained as a botanist, and then I moved into stereochemistry and then data science in the previous millennium itself. Currently, we are using BERT and GPT models for both biomolecules, not just proteins and DNA, but also chemistry, so chemical compounds. We are using a lot of genomic data, and we are trying to build models or large language models for understanding metagenomes in soils and environmental samples. So that's one bit where we use machine intelligence for the work that we do in plant biology and in environmental science. But more importantly, we've been, through Semantic Climate, involved in developing youth knowledge, in empowering youth to become knowledge champions through this program called Semantic Climate. The QR code is for you to share with your colleagues or join us as a volunteer. This is a group of people, volunteers all over the world interested in climate or climate action. We hope to take climate action to every individual on the planet somehow. And we want to do it through smaller internships. We are doing research, of course, in cutting-edge AI for climate data, for mapping climate data, but also internships, short-term internships from 10 weeks to sometimes 6 months for graduate and undergrad and postgrad students to sometimes, the solutions that you're looking for won't come from yourself from the coding that you're doing, but with youngsters who sometimes completely think out of the box. And so we are very keen on these internships that we do in Semantic Climate. And we encourage you to join us there. The big challenge we've had in this, because many of the interns come from India, there are also rural students, and we are very encouraging to rural students to join us. They're not very fluent in English, and our collaborators are in Cambridge and Berlin, and so English is generally the international language that people use to connect with each other. But within Semantic, we've discovered that multilingualism has come to our rescue. So one of our students, who was a rural postgraduate student in rural Rajasthan, one of the states in India, he said, I don't fully understand what you're doing, but I'm transcribing the Zoom call. So we all have meetings over Zoom. So he transcribes them. And then he says that what I can do is the stuff that you're doing with the IPCC, I can just convert it to my language, Rajasthani. And so we were very keen for him we were very surprised that he could do that. And this kid, he managed to build a little prosthetic, a knowledge prosthetic, which was in his language, after which we brought in lots of other interns from different states in India who also could then convert the same tools that we are developing, of course in English, into their individual state-specific languages. So we believe that has become a success story for us, or a way we have overcome the challenge of the language discrepancy. And I think that has happened again because of the fact that data science is not limited by language barriers. And I believe the language of coding somehow surpasses that, because these kids in different small rural cities and towns and villages could also work with us through this. So that's the bit that we've done for creating youth knowledge champions. And now I go on to what Deb Mohanty has to say. So Deb and I have both been very much involved in the last decade or so in how India is taking forward the priorities of a changing automation and intelligent automation all over the world. And so This talk, which is primarily Deba's, but ours essentially, is about how data scientists and bioinfrastructures in India are being brought together, a case study, you might say, from India. And I will also present to you insights from the Indian National Biological Data Mission. India has 9 missions, and much of the research, unlike the rest of the world, or much of the Western world, research in India is primarily funded by the government. And the government has currently, changing over times, but currently 9 primary missions, one of which is the AI mission, then there is climate security, food security, many others. But then under those missions, the government pushes lots and lots of funding for which different scientists and people, academics come together and then try to find solutions to the challenges within those missions. So what we have done is to build a national scale life science data ecosystem for India. Institutional readiness, interoperability, and governance are part of this mission. Balancing open access with ethical constraints and sensitive data was something that India wasn't even thinking about just a few years ago. But ever since I joined the International Data Policy Committee of CODATA, as well as the COERA, ERIB groups, I think it's each one of us adds to a drop in the ocean. And now within the task forces and policy frameworks in the absolute highest levels in India, we are very keen on balancing open access with ethical constraints in these sensitive data sets. India actually began with the biotech AI, at least the biotech boom in India happened in the 1980s with the establishment of a separate Department of Biotechnology within the Ministry of Science and Technology. And in realization of the importance of how data drives research in biology, right from its inception, the DBT itself in 1986 established another network called the BTIS network, or the Information System Network. And this was a network of bioinformatics or computational biology centers, as we used to call ourselves computational biologists, at least a decade ago, with a focus to bridge the interdisciplinary gap, also build information resources and prepare, databases. Matt just told you how everybody was making databases till 2 decades back, and now we don't talk about databases so much because there is no interoperability. And therefore, now more and more of us are thinking about data itself, putting a fair, recognizable, machine-readable data format into any one of the global repositories such as Zenodo, such as, where would you put it? We try to put much of our stuff onto GitHub and so on. In view of the recent advances that we've had in machine learning and AI, and the potential for biotech, AI-guided biotechnology in India, DBT has now, the Indian cabinet approved last year a new policy called the Bio-E3 policy. The Bio-E3 policy is about economy, environment, and employment built into these leading data science structures. And so Bio-AI is an integral component of the Bio-E3 policy, and I'm part of the Bio-AI hub where we are putting together groups of people, national and international, to set up Bio-AI hubs all over the country, at least in the north, south, east, and west. And within the northern Indian group, Deb and I are both handling the Bio-AI hub for India this side. There's a lot of research that is promoted by DBT again for the institutions that are autonomous institutions. So I represent National Institute of Plant Genome Research, which is where I work. Deb works at the National Institute of Immunology. There are 14 of us, as you can see on the tree up here in the map of India, in the network of autonomous institutions performing research in AI at the cutting edge of advanced models. The Indian Biological Data Center in this context comes up as, and the IBDC, it was established very recently. It is a national digital data repository mandated by the government to archive all life science data sets generated from publicly funded research in India. It is, of course, supported by the DBT, and it enables the implementation of the PRIDE guidelines, which are very important for India, particularly promotion of research and innovation through data exchange. So the IBDC is established itself in New Delhi. We currently have CPUs and GPUs. So the thing is, within India, and I believe this is true for most countries, every institution cannot have the infrastructure, every data scientist cannot have access to the infrastructure required for data science or AI and ML within your organization. And therefore, the IBDC provides this as a central hub to the rest of the country. So we have CPUs as well as GPUs. I think it's written on this slide somewhere. We currently have a couple of hundred, almost 1,000 teraflops of GPUs. It is mostly the A100 NVIDIA chips that we've got at the IBDC. In addition, we at my institution have a smaller phytocluster for plant biology with also a couple of 100 teraflops of compute power currently. But any institution, any university, and this is something that we've done in the age of intelligent automation, if you might like to put it that way, for young students, scholars, scientists, teachers, professors at universities, local, rural, regional, in case they don't have access to a large infrastructure of machine learning or machine intelligence, they can apply to the IBDC, they can apply to us at the phytocluster in NIPGR and get access freely, completely, based on the fact that based on the fact that an applicant is an academic and working in India, you have complete free access to the Indian Biological Data Center. In addition, the government has also made it mandatory that if I publish something today with biomolecules, with DNA or protein or any data set, which I have to anyway submit to GenBank, or the UniProt, we also have to now submit it to the Indian Biological Data Center, so that our data center, so that the National Repository does have data from everybody in India. There are many portals within the IBDC that are archiving genomic, proteomic, metabolomic, 3D structural data, phenome data for agricultural crops, clinical imaging data for biomedicine and health sciences. There are several network projects that India has which have generated together novel data sets to facilitate the applications of AI and ML for solving biological problems. Some of these projects are listed on this page, and these were the INSACOG, for example, was critical during the pandemic to provide all of the genomic sequences that were sequenced within India. These are all freely available to academics now for performing data-driven research utilizing large data sets. The Genome India mission or the Genome India program that India has is about AI-guided analysis of pan-Indian genome diversity. It's a huge data set of tens of thousands, I think, of genomes with millions of rare variants that have been discovered in the populations within India. And we are using this data to identify genes important for drug response, populations that make a substantial contribution to pharmacogenomics, and so on. The construction of a genome-wide reference imputation panel has also been undertaken within the Genome India project. So with that, I think I've given you some idea about how India as a case study is taking forward the idea of building capacity as well as building infrastructures as well as bringing our data scientists up to, making our data scientists completely aware of and ready for the challenges that we have ahead of us with the exponential increase in data. We also have development of different models that are predicting genotypic drug resistance in tuberculosis. We have a roadmap going forward within the BioE3 policy that I told you the Union Cabinet has approved, where we will be implementing cutting-edge large language models and explainable AI to propel biotech research and promote biomanufacturing in the country. There is geopolitical turmoil right now all over the world. India is facing huge tariffs right now, and the only way we can, I believe, move over these are by enhancing our manufacturing. And there is no manufacturing if you don't bring in biomanufacturing to overcome the green energy costs that we have to pay over and above the tariffs. We also have to pay a carbon tax, and that can only come down with biomanufacturing. So we are very much focused on that as well. There is a huge scope for Indian industry academia collaboration that we have with the bio AI hubs that we are currently, Deb and I are setting up together. And with that, I would like to thank you for listening to me and Debasis together for, for what we are doing within India in the age of intelligent automation. Thank you, Matt. Was that okay?
Thanks, Matt. Thanks, Gita. Hello, everybody. So I've been professionally involved in data sharing, stewardship, whatever you want to call it, for more than 35 years. And I don't want to make this talk about me per se, but the story of my career might help illustrate some points. So as some background context, I offer this Google Books Ngram showing the frequency that 3 terms, data science, data management, and information science, have appeared in books over the last 50 years. The data only goes through 2022, so it misses the current AI buzz. And since it's only books, it's a lagging and incomplete indicator. And moreover, the corpus is biased. We don't really know what it is. Apparently, it leans towards academic literature, so maybe that's good for our purposes. But anyway, I found it interesting, even if we can't take it too seriously. So I also want to point you to this paper up there at the top by Matt. He published a couple years ago in the Data Science Journal that discusses how the disciplines of information science and data science have always been somewhat fraught and contested. It's a nice piece. I encourage you to check it out, and it really helped me with some of the framing of this talk. Now here I add some milestones, data milestones, if you will, to the figure. Not that there's really any correlation per se, but there are some interesting things to note. First off, the World Data System and CODATA were established just as the terms were gaining currency. So they were sort of, ahead of the game, if you will. I think it's reasonable to think that satellite data had some impact on that, new types of data, new unprecedented volumes, that sort of thing. And then I think it's also interesting to note, as Matt pointed out, that the Data Science Journal substantially predated the explosion of the term data science. And then RDA got involved just as data science as a term was really taking off. And then finally, because it's not about me, I note that my career is right in the middle of this. This is when I got my first sort of data job. Indeed, when I really started getting into data management was when I took a job at the National Snow and Ice Data Center, handling satellite remote sensing data in 1993, the same year that the public web came into being. And data management was what we called it. That's what we said we were doing. It was the term all my colleagues, my mentors, used to describe what we did. And data management was a methodical, fairly well-defined approach. Catalog the thing, the data set, provide structured documentation, use a hierarchical controlled vocabulary, make it available in a generic format, often on media, sometimes through a simple open protocol like FTP. We'd share catalog information in a limited set of federated catalogs, but we weren't thinking in a networked way of doing things. It was really sort of thinking in that bibliographic sort of sense of how you manage information. The system was file-based and consciously or not modeled after existing document management systems, that sort of bibliographic thing I mentioned. And in my world of earth science data management, we were beginning to handle unprecedented, significantly larger volumes than libraries or archives had ever handled in the past. And the people that were doing the work largely came from scientific and engineering backgrounds, not information science backgrounds, not library backgrounds. The people only sort of had passing knowledge of formal library or information science. And I think, moreover, both the data management community and the information science community were perhaps a little slow to realize how this newly web-based, this World Wide Web thing, this web-based approach as opposed to a hierarchical approach to information could really change everything. And I don't think it changed our thinking as much as it should. And I think we still need to think in a more networked way. And I think we're beginning to see some of that come out in this conference over the last week. But then, over time, data became increasingly complex. The ability to interpret it and translate it to different communities became more challenging. At the same time, there was a growth of unanticipated use of data in communities that the original collectors had never thought about. In my world, polar bear researchers were using passive microwave remote sensing, something that we didn't ever conceive of. Surfers were using physical oceanography data. So we started to use the term data science to describe what we were doing, because we were doing research, applied research, around these issues of data analysis, representation, interpretation. We started using that term probably a little bit after DSJ was launched. But then before long, the term data science, meant something completely different. Following the explosion of not just earth science data, but all sorts of data, and I think notably the data about people on the internet and on the web. The web and internet were maturing into a routine utility, but we're also evolving to be dominated by proprietary platforms that I think were missing what I saw as the original intent of the web, of openness, standardization, and democratization. It was being closed up. And the dream of the semantic web was never really realized, and it remains largely a dream. And now, of course, data science is closely linked with AI. But I'm encouraged that the data management term also continues to grow, because I think data management, stewardship, whatever you want to call it, is essential to good AI and good data science. It's less encouraging that the information science term has declined, but I hope that's just an artifact of the terminology and that we haven't forgot the lessons learned, because I think there are a lot of fundamental lessons in there that still apply. Because one thing I see through all of this is that many fundamental principles remain the same, and we're still trying to figure out how to use the web or how to use a networked way of thinking. One more thing, it's fun to just note that the term big data trumped all of these. I just sketched that in there, Sharpie science. It just rockets off the chart and dwarfs all the others. And then just one other thing, also just for kicks, I did a Google Trends graph for the last 20 years. This goes up to just, last week or something. It's a totally different analysis than the Ngram. It's looking at, Google searches. But the growth in data science is roughly the same. And also there's this spike in both data science and data management just in the last few months. I don't know what that's about. But anyway, just for kicks. So enough about this dodgy data. Neither of these things should be taken too seriously. But as I said, one thing I see through all of this is that many fundamental principles remain the same. And we're still figuring out how to use the web. And so first off is preservation. We know what to do, but it's hard. And it's especially hard at scale. It's also urgent. It's extremely urgent. Many repositories are facing an existential crisis, notably in the US, of course, but all around the world. This is not just a US problem. And I just wanted to give a little plug here. You may have heard of a effort within the Earth Science Information Partners that I represent, working to improve repository resilience, led by Joseph Gum and a few others. So for immediate pragmatic things you can do, go to this QR code or esipfed.org/RCS, Repository Crisis Scorecard. So that's in the preservation space. But in the broader sense of preservation, we've long known that repositories could make more efficient use of core technologies, shared technologies. I mean, that's what the cloud is all about. But these shared systems can be fragile or capricious. And so how do we ensure in that centralized but distributed model that we retain the sufficient control as required by long-term archiving standards? I think that's still a really fundamental question that's actually become more fundamental in the modern age. I would argue that data ownership needs to be distributed to ensure this sufficient control and appropriate access restrictions, depending on the nature the work going on, and we've heard a little bit about this here, but not a whole lot, of networking different private data spaces or different data zones. I think that's really intriguing, and we need to be thinking about that, how places can maintain their ownership and share in a way that still maintains privacy, and that often the user maybe doesn't even know where the data came from. So I think that's an area that requires more exploration. And perhaps most critically, we need to recognize and preserve the people and knowledge that make preservation possible. Ultimately, preservation is a human problem. So then the other issue, and I think in this age of AI, or specifically LLMs and generative AI, we need to recognize that really it's just math. And math requires data to produce results. And important results need to be verified. The data must be transparent, and assertions need to have exact references, not just probabilities. And I think that's been a theme in this conference as well. As Agnes Caraga said yesterday, data moves at the speed of trust. And data science for research, and Matt was hinting at this at the beginning, requires formal trust. Assertions rely on verification through unambiguous reference, and by recording the history, the provenance, the supporting evidence for an object. And this needs to be captured in a graph with defined relationships as to how something evolved, that network view of things. And there's been a lot of discussion of provenance, and I think that's good, but we need to really start taking it seriously. We still don't take full advantage of a networked or web way of thinking in a formal way. We process vast amounts of bulk, unstructured data looking for patterns. We categorize nouns, but we only loosely define verbs and relationships. And I think we really need to focus more on those relationships and define those relationships. Verbs are important. So in concept, it's simple. Put more defined links in your metadata. Make your metadata link to other things and make sure that, and then make those links have meaning. And my screen keeps going blank. I think I have this down by now. There's some really good examples happening with this already, I think, in terms of doing these links. The Ocean Networks Canada is doing a really good job at this. GBIF is doing a really good job at this. The FAO, the Food and Agricultural Organization, has some systems that are doing great work on this. CODATA's new CDIF standard, emerging CDIF standard, is all about fostering relationships and emphasizing provenance. So we're going on in the right direction. I think this is good work for RDA, CODATA to really be focusing on. And then I'd also argue that showing provenance through networks helps democratize data by allowing many to define the nodes and edges of the graph. It's not just one repository doing that, it needs to be a distributed responsibility. And like I said, I'm really happy that there's been a lot of talk about provenance in this conference. And then finally, I still don't think we understand how we should be identifying things, be it data, software, instruments, what have you. But I do think that identifying things should be recognized in a way that is defined by how a thing relates to other things. A thing is defined by its relationship to other things, how it acts on other things, how it receives information from other things. So it's not just a PID, it's the relationships. And it's about relationships at all levels, and I think that's really should be the focus of data science, the sort of data science that we've been talking about here. And I think overall, that's exactly what the Data Science Journal was founded for. Codify what we know while exploring what we need to do with data to maximize its persistence, its trust, and its value. Thanks.
All right, so we're happy to open it up now. I appreciate these talks. Mark kind of gave us the trajectory, the history of data science and kind of this space that we all work in here at this conference. And Gita showed us where we're at now and where it's going with these amazing sources and systems that are being developed in India and around the world. So we're happy to see what you're interested in. If you want to follow up on specific talks, pick up on any of the themes. What are you seeing in terms of the trajectory of data science, what it means, how it's evolving, how it has evolved in your careers, your projects, and where might it be going? Anybody want to jump in first? All right, well, maybe where I'll start then is combining a couple ideas from Mark's talk and ask you, Gita. Mark was talking about provenance, connecting things, as well as the need to potentially not reveal all the connections if there's privacy, security, things like that. Some of the sources that you showed were biomedical resources, medical imaging, things like that. How do you think about providing openness and open availability and access to data in a sort of seamless way if possible, while also accounting for need to keep some details closed and protect privacy and so on?
Thank you, Matt. I think there's always a tension between academic openness and confidentiality of the data or the community who is providing that data. We navigate these tensions constantly through a balance that we try to, at least in India, what we've done, and to my knowledge, because I work also in Cambridge, some idea I have from the UK perspective is also that as long as you're talking about biomedical data, we can anonymize it and yet make it freely available for data scientists to be to be able to work on it and to find patterns. When it comes to biodiversity data, such as with the GBIF, India is not a member of the GBIF. Even so, much of the data, a major part of the GBIF data is coming from Indian citizens, from scientists, academics, as well as just citizens in India. And so I believe that this business of not being formally a part of GBIF is a government decision, whereas most of the people wanting to be part of GBIF, submitting the data there because of its provenance, because it can be used and seen by most other people, means that beyond a point we are open to having certain kinds of data sets freely available to the world for other people to be able to see, analyze, find patterns which we might not be able to find in those. Does that answer your question? Do you want to handle it, Mark, also?
No. So, any other thoughts? Yeah. We'll go over here then. We don't.
Hey, this is June from Terrestrial Ecosystem Research Network, Australia, University of Queensland. So I have a question for Gita. So you mentioned the semantic climate, and you mentioned like it breaks multilingualism obstacles. And I'm wondering, like, is it like a volunteering job for students and the communities? And how about the maintenance? Could you explain a bit more?
I'm so sorry. So thank you for that question. Semantic began actually within the during the pandemic. Earlier we were calling it open virus because it was during the pandemic that we discovered that openness is so important with data. We called it open virus initially and were constantly looking at it, and then then later we pushed it into more diverse climactic data, started working with the IPCC and United Nations. So yes, we have internships, we have research, we have a lot of outreach capacity building through hackathons, trainathons, datathons, not just within it, not just online and offline, and therefore we need a team of people, and we are a very small team. We don't have funding, we are all volunteers, so there's no I mean, we're not we're just a set of volunteers. The maintenance comes only through with each other. So much of our interns, many of our interns, they work with us for up to 6 months also. And once the interns have got an idea about the toolkit, about what it is that we are building through this, and we insist that every new intern performs, participates, and presents on an international scale. So at some point, by the middle of their internships, they're strong enough to become our maintainers for that period of time, but it's constantly, there is a turnover. And I think to answer your question, it is the turnover that is keeping us afloat. There's no funding, there's no, because all of us have day jobs, we all have to work with whatever we are doing. This is something we do because we feel very strongly about making a knowledge prosthetic that would be available to every school kid, every senior citizen, every retired individual, as well as every other person who wants to take action for climate. I'm very happy to talk to you about it later if you want to.
Hello, I'm Claudia Medeiros from the University of Campinas, Brazil. And I'm afraid to confess that I was at another session because I wanted to listen to another talk, and then I arrived here late. So, but I'd like to share and ask you about one of my main concerns around data science as it is used and perceived today by different kinds of researchers who think often about the analysis part and results of the analysis than of all the work that comes before it about, as you mentioned, preservation, curation, preparation, and the meaning of what it means to be a data scientist. You just don't need to throw AI or whatever at a big data set and provide answers. You'd have to think about the preliminary steps. How does this match with both of your perceptions of how data science works in your country? Not just the public. I'm not talking about the public, I'm talking about the researchers themselves.
So honestly, I think the term has become almost meaningless. One of the prompt questions that Matt gave us was, is data science a discipline in its own right? And it's a dozen disciplines. And it relates to, or it's part of many other disciplines. I think, I remember an old friend of mine saying that if you have to put science in the name, it's not science. And so I think there is a bit of that, and that's certainly what I think we were doing when in the early aughts, when we were saying, oh, we're doing data science because it's more than data stewardship, more than data management, and it was more. And there is research that needs to be involved with it, and there is, I think, research that needs to be involved in aspects of preservation and the social science of data science. I think is really undertapped. And that gets into the ethical things that Gita was talking about, but also just how we as a community enable the socio-technical aspects of infrastructure. One of the things I've been thinking about right now with the current data crisis is we don't have the social structures to be able to mutually support data centers that are failing. Matt made a nice point at lunch today and yesterday that we need like a NATO for data repositories. You know, that we all agree that if one fails that we will all step in to help. But that actually requires a lot of social structures. That's a governing science. So data science, I think, can be a really broad term, and I think it's maybe better to talk about more specifically what we're really trying to accomplish with the particular term. And if industry wants to run with the term in the direction that they're going, fine. But let's think about what we need to do in a research environment that has very different demands than an industry environment. And part of that is actually how research and industry interact. So I could pontificate on this for a long time, but I think I will stop.
Because your question has made me wonder about something totally, the fact that there is huge amounts of curation, pre-processing, and work going into even the point where you can begin looking at wrapping your head around the kind of data you have. And your question, you know, because from a point of view of researcher, what does it mean for a researcher like me doing that business? So the problem there is a quagmire. It's like a hornet's nest when you start touching it. Because what you've touched upon is that the credit for doing the analysis and seeing the outcome belongs to somebody who did not do the curation, who did not do the pre-processing. The promotion in jobs, the recruitment, the research assessment is all done on the final outcome. Nobody cares about the whole process that led to the outcome and the work. The analysis was possibly a software, click a button, get it done. But who prepared the clean, fair, machine-readable, interoperable data? I did that for 16 years. But now you're using that data set and you're publishing 15 kinds of things from it. I don't get the credit. And data scientists, least of all, because it is the validating experimental. In India, even the funders are constantly asking you, oh, you're just a data scientist. Where is your real guy, the guy who's the validator, the experimental person? In papers, the corresponding authors are generally those who are the experimental guy. What about the data? What about the efforts that we've put in putting your messy data and cleaning it out? And so therefore, I think we need to make this more visible. We need to talk more about this. And I'm so glad, even if you're late, you did come in and discuss this, because these are things which are very difficult to articulate. These are issues which need to be discussed outside of this room, with non-data scientists, so that they understand how important it is. And so it touches upon research assessment in a very big way, which is a different thing. I think that's not, today's platform is not for that.
Comment over here.
Hello, I fully agree with you, and I would like actually to mention that in a recently not very long published EOSC Federation handbook from Europe, there is written that the biggest output from research are articles, are publications. So interpretations, scientific interpretations of the data. And this comes from data infrastructure. So this comes from the community. Unfortunately, it's more policy people who were writing this document, so this is why it is there written in this way. There should be clearly written that the data, or good quality data, are the biggest outputs of a scientific effort. And it is not even in the data infrastructure document written in this way.
You want to respond to that? I'll just note, I remember early in my career at NCAR about 15 years ago, talking with the scientists, and his comment was papers are more important because anybody can collect data, but not anybody can write the paper that analyzes the data. Forgetting the fact that not everybody can collect good data or valid data or all of the things that have been talked about here, not to mention that it's incredibly hard to do that well. Yeah.
Well, now we know that this person was wrong, because ChatGPT can write beautiful paper based on on whatever data, but ChatGPT cannot create the good quality data.
That's a great point. That's definitely an evolution in data science here. Other thoughts and comments? So another thing that I would ask then, that I think you touched on, Gita, maybe Mark, I'm interested in your perspective here too, but how ethics plays into all of this. I think that's something we've seen in evolution in as well, especially as AI has come in, ethical standards for AI, ethical use of AI. How does that fit into what a data scientist is? How does that fit into, say, the programs that you're building on, the systems that you're working on, ensuring that ethics and the use of ethics is appropriate in these contexts?
Oh, I think there's lots of places. I think the plenary session yesterday touched on a lot of that in terms of the needing to validate the proxies, for example, and that's what I was sort of getting at with that you have to have unambiguous reference behind your assertions. It can't just be a probabilistic guess. Or if it is a probabilistic guess, you have to say what it is derived from, and so there's many ethical dimensions of data, particularly when we're talking about human subject data from indigenous peoples. But I think just the concept that AI pretty much amplifies all human flaws. And so we need to be very careful about what we are feeding into the AI and in the way that it can be transparent, understood, so that we are not perpetuating, like the speaker said yesterday, you know, that you have a bad proxy. It's just going to amplify that. And so, but if you can't make that transparent and visible, that's actually an ethical failure. That's not just a scientific failure.
I just want to add to that, that the ethics of the data itself or the tools that we are building, the transparency, anonymity, are on one side. Equitable access is before all of this. And so ethics, we can't even begin to talk about ethics unless the data and the analysis are available to everyone. So equity before ethics is what I would say. And coming from the Global South, I believe that we are lagging behind in the equity part itself. And then comes the question of ethics, which could be, as Mark has just pointed out, within the software, within the code, or in the data, or in the people, or the provenance of the data. On several levels, we have to address the question of ethics, absolutely, but equity first.
Thank you very much. So just for people online, Amir Aryani from Swinburne University. I have a question related to the approaches of early career researchers and scientists in different countries. So there was a recent report from IMF that shows across the globe about 60% of jobs get affected by generative AI. But when it gets to the developing countries, it's only 26%. So there is a discrepancy there in that space. Now, when it gets to the science, how much we have a similar discrepancy? Do you envisage that there will be a substantial difference between the scientists in Canada, UK, Australia, India, Japan, Russia? Would that make a big difference of where are we as a scientists and what information we have available to us?
Yes, it's all right. I ate a small lunch.
So this is news to me. I was not aware of such a huge discrepancy in numbers already with the IMF, and I would like to probably read that later. I can meet you up. And what I believe, what I have seen, and because I don't just work in India, I also work at Cambridge, and I'm very closely associated with the European Union CODATA, and I would say I'm reasonably international. What I've seen is that I don't see discrepancies. Despite national, religious, language barriers, the problems that scientists face, early career researchers or established scientists, are very much common through these borders of national boundaries. I've felt not just the challenges, I believe that our strengths are also very common across these boundaries. And so therefore, I personally would not, I haven't seen such differences. I believe that early career researchers are using AI much, much more than established researchers, because these youngsters, they were born with the digitized world around them, and they are so much better at prompt engineering than we are. But beyond that, as far as your point about jobs being impacted, in India at least, what I've seen in the last 2 years is that generative AI has brought about a huge layoff in the corporate sector. In our major international corporate giants have laid off mid-career people, not the youngsters, not the very senior people, but the mid-career people. And this is not science, this is general corporate. But within the scientific system, what I'm noticing is that more and more youngsters are being hired because they seem to know more about generative AI than people who are more established or senior academics and researchers. But I may be wrong. I mean, I've not really thought about I believe AI is an extension of oneself. Like when the Y2K happened, all of us thought that, oh my God, something's going to happen. I didn't sleep on the night of the millennial change at all. I was on the streets walking about, what if the Y2K monster comes in? Then when the smartphones became so critically, everybody said, oh, that's taking away your individuality, your humanness. But the phones are now an extension of ourselves. And I believe AI will also be a kind of extension of ourselves, so more human-machine interface. taking away our jobs? Yes, jobs are going to become, jobs have always been tough.
Yeah, I don't really know, Ari, but I will just make a couple comments. One, technology almost invariably reinforces existing power structures. Yes. So the privileged gain a bit more than the underprivileged. It typically reinforces existing power dynamics. AI in the broad sense, so, and we, AI is a dodgy term because it's very broad, but generative AI, for example, the trendy stuff with the chatbots and so on, is trained by a very narrow corpus of knowledge from the world. It's what's on the web. It's typically in English. It's typically from the Western world. It's not considering other ways of knowing at all. And so I think that it's the equity issue that Gita raised that I think is a concern that I would bring in here. How that affects employment and actual economic benefit in different environments, I'm not really sure, but it will. I would be willing to bet money on it that it will reinforce existing power dynamics. We should see if there's questions online.
Yes, but does that answer your question? We need to have some more discussion on that, but I don't see what's there.
Yeah, it takes further depth.
Thanks, Mark. I've got a few related comments. One is about the changes that technology imposes, and I regard generative AI as another in a series of technological changes which we have to deal with and to which we have to adapt. One of the things I'm particularly concerned with whenever those technological changes happen, as Mark said, yes, social inequalities, power structures, etc. I think they also force us to consider again epistemology. How do we know what we know? At every step when there's a technological change and something new in the way we conduct science, or in the technology we use in our daily lives, we need to ask as citizens and as scientists, how do we know what we think we know? And I think AI, generative AI, the fact that it comes from that, that limited corpus, even though we think it's huge, requires us to address that question as scientists and as citizens. I also wanted to comment on data science, data stewardship. There's a nice session in here yesterday. Was it yesterday? I'm losing track as we get to day 3 of the conference. Again, this data science, data stewardship relationship, the Phil Bourne blog post about the 2 universes. I've got a lot of time I think we need an ongoing discussion about that. One comment I made, which I think is reasonable, is that data stewardship and what we think of that being needs to become more data science-y and needs to become a lot more AI aware. And conversely, the data science curriculum, as it's taught in many universities, needs to import a whole load of stuff from our practice as data professionals and data stewards. And in particular, that engagement with scientific methodology and how we know what we know, the provenance and context of data, and how we track that. And I'll close. So this is a comment really rather than a question, but maybe people will want to respond. I still like the passage from the Data Science Journal Scope, which says, "We regard data science as the science of data, the evidence-based study of the socio-technical developments and transformations that affect science policy, the conduct and methods of research," and that epistemological point, "and the data system standards and infrastructures that are integral to research, and how they're managed, and how they're funded, and what they have to do." That for me is the science of data. That's what we're about. And we're adapting, very exciting, it's very interesting, in the present time, the last few years, to, okay, how do we incorporate an understanding of generative AI and everything that goes along with that to our understanding of data, and what does that mean?
Yeah, thanks, Simon. It's something I think about a lot on the editorial side of the data science journal as we get submissions. We're not an AI journal, and I said a little bit about that in the introduction, but we're getting more submissions from that side of things, and how do they fit into this? And I think, how do we connect these ideas of the AI work to what is the science of data, as you said? It's kind of a case-by-case basis at present, but that's something that we can perhaps articulate better. But either if you want to respond to Simon's comments? They're agreeing. We have a comment here in the back.
Johan Philips, University of Leuven. I would like to respond to the last speaker, to Simon, where he said that data steward should be more data sciencey, and I fully agree to that. I was a data scientist, now I'm in a data stewardship world, let's say. But it involves a completely, upskilling of the workforce in our teams, let's say, that they shift from information scientists to more data scientists, and that it's been a struggle to see, at least we tried for about research software, we tried it with other things that we see that these things are important, that they have knowledge about and they can give advice about, because it's more than just data and fair data, it's also about fair software. But they struggle to capture these concepts, or they struggle with being confident in giving advice to researchers on these topics. So I want to relay the question back to you or to the speakers on how can we set in motion such a way to make data stewards more data sciencey.
Do you want to respond to that?
I mean, my personal response to that is that data, so information science, iSchool, curricula, data stewardship courses, we need them, and they need to be more ambitious. The iSchool curriculum needs to be more ambitious. That perception of that information science role is just not enough for the modern world. People in iSchools, etc., know this, and they're discussing this, and so I want to be a bit cautious in sounding as if I'm sort of preaching. But those curricula that, one, we still need data stewards. It's not going to all be AI. So we need to generate that workforce. Certainly in Europe, they know that. A lot of institutions that are employing data stewards in Europe are largely taking people from the disciplines who are, with scientific training, and then adding the data stewardship training to that. So it's more of okay, you need to have a scientific training, and then you need to have the information science, the data science, the data stewardship skills. So it sounds more like a sort of a graduate professional course at that stage. But I'm sure we can, I'm sure in this room we could sit down in an hour and design a very effective postgraduate data science course or data stewardship course to cover those things. But it just needs to be put into practice.
As I'm walking, I'll say I do teach a data curation course at University of Washington Information School, and I didn't teach it last year, but we'll be teaching it again in January. And I'm thinking about how to bring these ideas in, right? You can't throw somebody who's not a technical person into the deep end, but how do you walk them into these new techniques?
Yeah, I would like to add here, because I think we are using the term data stewardship in an extremely broad sense. And just from my own experience in Herovsky Institute in Czech Republic, actually sorry for not saying the name, Marek Sobica from Herovsky Institute in Prague, I was actually the person who created a structure where we have a support team. We still call them data stewards. And here we are moving towards data scientists and real IT experts. But managed to get one data steward per 10 researchers in our institute. It is part of the team. It is scientists, and for, let's say, 10 to 20% of their work time, they help others, but they with the data management, and but they have the skill. So it's a skill in this particular case. These are researchers, these are PhD candidates usually, but this is a skill they are getting from us, from the team, open science team, which to help others to move. To improve their ability to handle the data in a modern world. So I think the thing is that we are using the word data stewardship in an extremely broad spectrum of positions, because data curator is slightly more specific position.
Yeah, I would agree with that. There's lots of types of work involved in data stewardship, data curation, as well as obviously data science. Do either of you want to respond? Sorry, it sounds like we're hearing some noise from the back. We might be getting some noise from the back. Do you have something? It's from outside? Okay.
Sort of lost my train of thought. Oh, well, one, I really like what you're saying, Simon, that we should make data stewardship more data science-y. My experience with data curators, at least, is they tend to be a fairly conservative bunch. I think it sort of comes with the nature of the job, and in many ways that's a good thing. But it's hard to sort of get them over the hump. That's I think what you were sort of getting at. And then just as an anecdote, I have this argument all the time, and I don't know which side I'm on, that because I mentioned in my talk that when I was first getting involved into what we call data management, the people largely came from scientific and engineering backgrounds. And some say it's easier to train the scientist in information management, and some say it's easier to train the information manager in the relevant discipline. I don't have a side in that argument, but some people have very firm sides in that argument. And so it's just an interesting, dynamic. I think it's a cultural difference. And then finally, Simon said we could sit down in an hour and sketch out a curriculum. Well, that would be an excellent CODATA effort or an excellent RDA working group. We have the SWORDS program, the RDA CODATA data science for early career people. Let's add a data science in stewardship component to that.
Yeah, I think providing guidelines on how they can connect to each other. There are lots of curriculums for both, but how do they connect to each other?
Actually, Matt, I think that's a very good point. Just on, we are reviewing the offer for education training, for SWORDS. We are of the view, or the CODATA Executive Committee, the officers at least, are of the view that we need to do some updating. It's been a very successful, a really valuable contribution for 10 years, but it needs some thinking about the content and about the approach as well. So, hopefully we can get some interest in being involved in that reflection and making it practical as well, delivering something useful. I wanted to make another comment as well, which is, if we look at the disciplines where expansion in at least a form of data stewardship have happened, it's in the informatics, the bioinformatics area. In that area, because of what needed to be done in the science, there was a huge expansion in those roles. And in fairness, those people are largely subject scientists who have then developed those informatics skills. And so I think in these discussions, I sort of lean towards the latter, and I think it's incumbent upon each research area to say, what are our needs in terms of the information that we need to have at our disposal and the data we need to have at our disposal, and how do we generate that team of informaticians to do that work, albeit with AI assistance now.
here first.
This is Claudia from Brazil again. This is part remark and part suggestion, because I've been in contact with some German philosophers who pointed out an excellent book to me called Why Trust Science by an author called Naomi Oreskes, in which she discusses, this 2019, all the problems in trusting science and ideas in which we can collaborate. And one of the things that struck me is that she describes science as a collaborative enterprise. And translating into the question that's on data scientists, automation, AI, we can collaborate through data. So in that sense, how can we add philosophy, which data scientists, you know, and lots of the exact sciences say we don't understand a thing. And we do not see how to add philosophy and even ethics as part of what we should be worried about. What do you think of it? I recommend the book. That's why I don't get any commission out of recommending it, but it's a great book, and I think everybody should read it. How do you think about adding philosophy to this melting pot?
Yes. It's the epistemological issue that Simon raised. Yeah, I think thinking about how we think is really important. And if anything is challenging that, it is AI. So.
Yes, that's it.
In terms of the question of education and, do people come from either side of science versus data management, I've been involved in various data training programs, and the way I think about it at this point, and I came from an information school, is people who come from the information school tend to see the big picture and not have the specific skills that might be immediately needed, whereas people who come from the disciplines tend to have the specific skills in programming and dealing with the formats and all the idiosyncratic things that disciplines deal with, and then need to learn the bigger picture over time of how metadata connects to preservation, connects to search, connects to all those things. And so I think it's not better or worse. There's just a different sort of starting point. But I think you mentioned something in your talk, Gita, about bridging, data as a bridge. And I think that's something we've also seen, is that data-focused people are often bridges between all of these fields, including people who are on the philosophy and the social side. So I think that's one of the benefits of having a data-focused education that does encompass sort of the full picture that we've described, is understanding that those pieces exist, that they all connect or need to connect, and that there might be people who need to be connected in order to have those things fit together. And I think that might be something that's not as visible for somebody who's coming from a discipline with that perspective as they come into this field. All right, let's see. Well, we're about 3 minutes from the bottom of the hour, so any final statements? All right, well, I'll just say one thing, which as the editor of the journal, I feel obligated to say, which is we'd be very happy to have any submissions you have on this topic. Again, we invite people to sign up as peer reviewers. I will say if you're doing presentations on other topics, we'll have a running special issue for International Data Week focused material. So take a look at the submission process and the guidelines and all that if you're interested in putting something else into our journal. We'd be happy to have anything added to that special collection. So I think with that, I'd like to thank our speakers again.